question and circle the correct answer. So your quiz was what are some forces? Sophia, could you read number 1?
Two dogs are the same size and weight but acted in opposite direction. Which of them describes the fox of two dogs?
And let's circle it. Let's have everyone circle it. So you guys can all annotate in 3, 2, 1, go. Okay, you guys are correct. This is a balanced force. This is a balanced force. So it is a balanced force. They're pulling with the same strength. And then they are the same size and they're pulling in the same direction. Okay, let me clear that. Balance forces is the answer. Okay, let's keep on moving on. Number 2, who can read number 2 for us? Let's have Kim. Kim, can you read number 2 for us?
One just hit the baseball with a bat. It changed direction of the ball, which is a true statement about force on a bat and ball.
Okay, guys, read number A, B, C, and D. Read all of them, and then we're gonna yell our answer. We're gonna yell our answer. Okay. Okay, in 3, 2, 1. Okay, you guys are saying A. I'm hearing a lot of A's. The forces are not balanced, and the bat pushes with more force. That is correct. Let's do number 3. Everyone should know this. What force pulls objects towards Earth? Everyone. In 3, 2, 1. Gravity. Gravity. You guys should have answered C. You guys should have answered C. Gravity. Okay, so we have a bird, a tree, a cloud, and a dog. Which objects are pushing or pulling on each other? I'll just call on one person this time. Let's have Sarah. Sarah, which ones are pushing or pulling on each other?
Your bird and the tree.
And how did you know it was the bird and the tree? What are they doing? Are they contacting each other? Are they touching each other?
On the tree, then the tree.
They're touching. They're touching each other. The bird is standing on the tree, and the tree is holding up the bird. It's pushing up the bird. Very good. If a bird is too big, maybe it will snap the branch. Maybe it would snap the branch with too much force pulling down. Okay, good job, guys. It's the bird and the tree because they're touching. Let's have someone read the next question. Let's have Banana. Banana, can you read the next question?
Race car with the same mass starts moving on a racetrack at the same time. One car reaches the finish line of the track in 50 seconds, and the other car reaches the finish line in 20 seconds. Why did the car take different amounts of time to reach the finish line?
Great reading, Banana. That was a long one. Good job. That was really good. So A, B, or C, was it the force of gravity only slowed down one car, not the other? B, there were no forces on the second car, so it moves more slowly. C, the forces were balanced on one car and unbalanced on the other. Or D, the engine of the faster car pushed with more force than the engine of the other car. Let's have Milk. Milk, what do you think?
I think.
Why did one car win? Why was one car 5 seconds faster?
The engine of the faster car pushed with more force than the engine of the other car.
That is correct. It is D. The engine pushed with more force. Gravity, both cars are being pulled down to Earth. Both cars are pulling down to Earth. both cars are unbalanced because both cars are racing. They're both unbalanced, so this is not true. But yes, D is correct. D. Zoe puts a pencil on the desk. The pencil does not roll. Explain whether the forces are balanced or unbalanced. What do you guys think? I'm going to unmute everyone. Are they balanced or unbalanced? In 3, 2, 1, go. What is it? It's okay, and why? Explain. Are the forces unbalanced? Raise your hand if you know. Why are the forces balanced? The pencil does not roll. The pencil does not roll. Why does it not roll? Let's have Taylor. Taylor, type me in chat. Taylor, why does the pencil not roll?
Because it is unbalanced and the table like it is not it is straight, so the pencil can't roll down.
Okay, it's a fair explanation. And Scart, what did you say for this? Scart, what?
A pencil is balanced on the table.
When a pencil is balanced, or when a pencil has balanced forces,
it doesn't move. It doesn't move.
the object or the pencil will not move. Yeah, guys, remember balanced forces, the object isn't moving. When a pencil has balanced forces, the pencil will not move. The forces would have to become unbalanced. The forces would have to become unbalanced. If Mr. Connor pushes the pencil, it would become unbalanced and the pencil would move. This one was the hard one. This one was a little bit harder. Jack.
Oh, very clear.
Jack, could you read it for us? Mr. Lean's
Class is doing an experiment. The setup is 2 ramps of equal length. The real measure of force need to pull each car up its ramp. Explain which car will take less force to pull up the ramp.
Which one do you think takes less force, Jack? Which one do you think takes less force?
Second one.
The second one. Okay. Let's have you guys circle. I want everyone to circle which one they think takes less force. In 3, 2, 1, go. Circle A or B. Kim chooses B. Ray chooses B. Rose, Sarah, Sophia, Puppy. They choose B. Okay, everyone chose B. So everyone knows why, or that it's B. But why? Let's have Puppy. Why do you think B is easier to pull a car up?
Because the ram was straight than the beam.
Okay, very good. Straighter than B. Lisa, what did you say? Lisa, what did you say?
Because the ramp is steeper.
Yeah, because ramp A is steeper. Ramp A is steeper. B is not as steep. Very good. Sophia, what did you write? Why is ramp B easier to pull the car up?
I only to forget it.
Okay. Okay, guys, I'll type out the answer or a answer. You guys could have written something similar. Ramp A is more steep. Ramp B is less steep. Another way to write this, guys, if you didn't use the word steep, you could have said ramp B is not as tall. The taller or more steep the ramp, the harder or the more force it takes to move up the ramp. Okay, guys, so this would be the correct answer. The steeper or taller the ramp is, the more force it takes to get up the ramp. Now let's get on to our new lesson. Hopefully that wasn't too hard. Okay, let's have a little fun with our next lesson. So lesson 3, we're gonna start lesson 3 today. We have some fun activities. I have a fun activity for you guys to do at home. So lesson 3, forces from a distance. What are some forces that act from a distance? What is a force that we learned about last lesson that acts from a distance? From a distance. Remember, this force does not have to touch you. When something acts at a distance, it does not have to touch you. Let's see, let's have moon. Moon, what is the force that we learned about that acts from a distance?
Motion.
Not motion, it's a force. What pulls things down to earth? It does not have to touch you.
Gravity.
It is gravity. It acts from a difference. Good job, Moon. It is gravity, guys. We have gravity. I have a little picture here for you guys. Well, what are you waiting for? The astronaut says. The other astronaut says gravity. Gravity, there's not enough gravity to pull him down the slide. What is another force? What is another force that you guys can think of that acts from a distance? We have not learned about it yet. Think about something that can act from a distance. Does anyone have any ideas? Raise your hand on Zoom. I'm gonna check Zoom. I'm gonna unraise everyone's hand. Lower all hands. Raise your hand if you have a force that you can think of. Sam has one. Oh, Sam had one. Jackie, Sam, Zook. Okay, let's. Jack.
Magnetism.
Magnets. Exactly. Wow, that's magnetic slime. That is magnetic slime. Yeah, magnets work from a distance. They're not touching, see? They're not touching, but they can act from a distance. There's one more. Does anyone have another idea? I'm gonna lower everyone's hand. Lower everyone's hand. There's one more we're gonna learn about. Pasta?
Gravity.
Gravity, yeah, we're gonna be learning. Yeah, gravity is one. But that's not what I'm thinking about. We'll have Sam try. Sam, what's one more that acts from a distance?
I don't think it's right. I think it is wind. Maybe.
Okay. You know, wind is sort of right, but the wind is actually physically touching you. It's the air touching you, so it doesn't act from a distance. But that's a really good guess, Sam. That's a really good guess. But it's static. This is going to be a hard one. It's electricity, static electricity. Look at that boy's hair. Look at that boy's hair. Daisy, could you read it? Could you read this for us, Daisy?
By the end of this lesson, you'll be able to ask and answer questions about forces between objects that are not in contact with each other.
Good job. And Daisy, what does it mean when an object is not in contact? What does it mean when an object is not in contact? What does that word contact mean? We learned about it last lesson. What does the word contact mean?
It
It means
means touch.
touch. It means touch. Exactly, Daisy. Contact means touch. So this lesson is all about objects that aren't touching each other, using forces that aren't touching each other, like gravity, magnets, and electricity. What is this object called? What is this object called? Taylor, what is this object called?
It's a magnet.
It is a magnet. And what can you tell me about magnets, Taylor?
When we hold it, maybe it will stick to something like metal.
It might stick to something like metal. Okay. Let's have raise your hand if you would like to go. I'm gonna lower. Make sure you raise your hand if I have not called on you yet. Let's have Sino. What can you tell me about magnets?
If they have magnetic force,
They have magnetic force. Yeah. So these are some magnets. These are some magnets. Let's have Lisa. Lisa, could you read for us? Lisa. Magnetism.
Magnetism is a force that acts from a distance.
Magnetic.
Force surrounded magnets. These forces cause magnetic force objects to push
Apart.
apart
Or pull
or pull
toward each other without touching. Thank you, Lisa. You said some really hard words like magnetism, magnetic, magnets. Okay. Okay, guys, get a piece of paper out. Write what you see happening in the picture. Write what you think is you see happening in the picture. Write what you observe. As you write, tell me what you think might cause the effects that you see. Everyone should have a piece of paper and a pencil. Get it out. If you don't have one, go get one. I'll give you guys 2 minutes to write your answer. 2 minutes to write your answer. Tell me what you think is happening. What do you see? Talk about the different magnets. You could talk about the green magnet, the red magnet, the blue magnets. What's happening?
I think the green and the blue one are the same magnet, because the magnets north and northeast will push each other.
You should write that down. You should write that down. I think that's a great answer. One more minute, everyone. One more minute. If you want to type me in chat what you wrote, you can do that as well if you're done. Taylor thinks the magnet's gonna come off the top, I think. Come up to the top. Let me change my screen so I can write. Let me change my screen so I can write. Well, I guess while you guys talk about it, let's I'll leave the pictures up so it's a little easier. I haven't called on Funny yet. Funny or Bunny. Lucky, what did you write?
I think the magnet makes the hands can't touch the magnet.
Okay. I like it. I like it. It's a good start. It's a good start. Let's have Rose. Rose, what did you write?
I'm not finished.
Okay, you can finish. Let's see what Scart, what did you write? What do you think is happening in the picture? Write what you observe. As you write, tell me what you think might cause the effects you see.
Each effect the choice.
Yeah, but you got to tell me about the magnets. You got to try to talk about the magnets. Okay, try to write that down, okay, Scart? Let's have Sophia. Sophia, what did you write?
I think the magnet will go out.
Okay, it's going to fall off. It's going to come off.
Yes.
Okay. So Sophia thinks the red magnet is going to push the green magnet right off. That's fair enough. I'm going to go over the answer, guys. So all you have to do is observe. You could say some of the magnets seem to be pushing on each other. Other magnets seem to be pulling on each other. Different colors might be different, or different colors might be a different, I guess, type of magnets. Okay, some are pushing each other, some are pulling each other. The different colors might be different type of magnet. You could talk about You guys are right to observe the green magnet might fall off or might be pushed off of the top. Like you guys said, like Taylor said. You can write down whatever you guys observe, though, okay? Just tell me what you see. Anytime it says observe, anytime you guys see the word observe, just tell me what you see. Okay? Let's read about a magnet. What time is it? I want to make sure we have enough time for your activity. Okay, this is the last thing we're going to do. We're going to read about a magnet. Okay? Let's have Emma. Could you read about the magnet?
Magnets everything. Stick to this. A magnet is an object that attracts things made of certain metal. You may have seen or used magnets at home or at school. You can find all the magnets in this house.
Okay, so thank you for reading. These are some magnets you might find. Speakers have magnets. A magnetic holder. Magnets in your shower holding different things. Purses and wallets. One of your mom's purse or wallet might have a magnet. A vacuum cleaner actually has magnets in it. And the most common place to find a magnet is on your refrigerator. Some people have magnets. You guys probably all have a magnet on your refrigerator. Okay. We'll read about them next class. So your homework, all your homework this weekend is to explore your home and find a magnet. Write what the forces of the magnets are used for. Is it to stick something to your fridge? Is it used to close your mom's purse? What is the magnet used for? And where are you able to find any other examples of magnets? All I want you guys to do is write me a few examples of finding magnets in your home. This is an example. I explored my home and I found a magnet. There are magnets on the bottom of my chess pieces. The force of the magnets is used to hold the pieces to the board. This stops a chess piece from falling over or falling over the board when playing. This is what I expect. Guys, you have the whole weekend to write something. This is something I would expect. This is an example. Let me show you real quick. So look at Mr. Connor. Let me spotlight my video. So Mr. Connor has a chessboard. Okay. And this one's special. This one's actually kind of special. Oh, don't fall. My chessboard has magnets. All the pieces are magnetic, so they don't fall. That's why these pieces are not falling. You can pull them off with enough force. You can pull them off, but the chess pieces want to stick to the board. See? Mr. Connor's chess pieces are magnetic. Now, this is a bonus activity. A bonus activity for fun.
Bobby.
I have an activity where you guys can make this magnetic slime. This is a tutorial. You can watch these videos to make slime. Now, the only thing you need to make your slime. So, the only thing you need to add to your slime to make it magnetic is something called iron filings. And you might be like, Mr. Connor, I don't have any of those. Well, I'm going to show you how to find them because you guys can find them. So there's a video of a girl showing you how to find them, but Mr. Connor will show you quickly. So Mr. Connor got dirt from outside. I went to my park. I went to the park next to my house and got dirt. You guys can see the dirt.
Dirt or sand?
It's sand is better, but I dried it off first. I made it really dry and I took all the big rocks out, but this is dirt and sand. I found this on the street as well. Okay. Now, let me show you how to get it out. I'm going to use the magnet I found. This is my chess piece. The stronger your magnet,
Can I use the dirt from my plant?
maybe it might work from your plant.
Can I use this one?
What?
Yeah, you can use any magnet to do this.
My home has so many plants.
Yep. And you might be able to ask your parents to go get you a cup of dirt. So guys, I covered the magnet with a tissue. And now watch, I'm gonna just move around my dirt. I'm just moving around the dirt with my tissue.
I can see.
And it's okay, I'll show you. And look, you guys see that circle there that just formed?
Black?
I'm gonna show you guys a picture. I got a picture of it.
Yes.
Here is a picture of it. This is the iron filings. You guys can add these to your slime. You guys can add these to your slime and it will become magnetic.
It makes from sand, right?
Yeah, from sand.
Just sand.
Just sand. The sand has iron in it. This is iron. You guys can see the iron on the camera. But yeah, you guys can make this at home, okay? I just want to bye bye guys.
Bye.